Mick is currently the Chief Data and AI Officer at the Office of the Undersecretary of Defense for Intelligence and Security at the DoD. In this role, Mr. McCabe leads enterprise-level efforts to harness the power of data and artificial intelligence in support of national defense priorities. McCabe is responsible for shaping and implementing DoD-wide policy and capability initiatives that support mission agility and secure data modernization across the intelligence enterprise. Prior to this appointment, McCabe held senior positions across the Department of Defense, specializing in intelligence operations, mission data integration, and emerging technologies. He's a veteran of the U.S. Army, go Army. McCabe brings more than 3 decades of leadership experience in information warfare, joint intelligence, and cross-function mission alignment. He is a recognized advocate for cross-agency collaboration, strategic use of AI, and modern data governance to bolster U.S. security and defense readiness. Everyone, please help me in welcoming Mick McCabe.
Good morning, everybody. Thanks for having me here. I've got some prepared remarks, but we can go a little off script if you like. So, as I was introduced, I'm the Chief Data and AI Officer for the Undersecretary of Defense for Intelligence. I've only been in that position for about 5 months, but I've been doing data type work since 2015. We're kind of at a critical juncture right now, and the story I will tell is I was running operations during the war, and we were using data to do a lot of things, mainly risk mitigation, stuff like that, really understand what we're trying to accomplish. What I found was we had so much data that, am I too loud? All right, we had so much data that we couldn't use it all. So we were making decisions on a timeline, and we were making them leaving a lot of data on the table. All right, excuse me for 1 second. All right. So, anyway, that kind of stuck in my craw, right? I didn't like the idea that we were leaving a lot of data on the table and couldn't make our decisions in a timely manner using it all. We're not there now, right? Today, as everyone knows, technology is at our fingertips. What used to take a supercomputer now can be bought for a cloud instance. The algorithms that we're using have become so much more advanced than they were 10 years ago, 20 years ago. And the data we have is unbelievable. The amount, the deluge of it. Every soldier, every sailor, every satellite, every vehicle we have is a source of data. Our challenge now is using our compute power, our storage power, our algorithms to make sense of that data in a timely manner. That's where we could use your help. For defense intelligence, it's not only a data change and a tech change, it's a process change. And what I mean by that is, we've been doing business the way we've been doing business for a long time, and it's very product-based, right? We take intelligence, we take data, we do an assessment of it, and we provide that assessment as a product. Now, we have the ability to provide data as a product. And what I mean by that is, for a good example would be targeting. So we have the ability to track vehicles, people moving. We've got a lot of sensor data coming in from satellites. We've got a lot of sensor data coming in from ISR. We can do a real-time track of that thing. We can identify it in near real time, and we can track it in near real time. That's no longer an intelligence product. That is a data product, right? That's not an analysis product. That is the fundamental shift that we have to embrace to be able to make better use of our data. So the first thing you do when you realize you can do that kind of stuff, is you start hiring data scientists, building instances, and doing boutique data operations. And we've been very successful at that for about 15 or 20 years now. The problem is, when you try to scale that, you've got to go back and fix your data. So I will tell you, fundamentally, that's the first thing we need to do to move forward. We need to get our data right. What does that mean? Data interoperability built in. I'm sure everybody is familiar with, the whole idea of data centricity. And in a nutshell, data centricity says you put data in the middle of everything and you build services around it. That's easier said than done. And now we're moving on to what's called a data mesh, if anyone's familiar with that, which means you'll have a bunch of data-centric, enclaves talking to each other. What goes on in those enclaves is very, very business specific. And what I mean by that is, if you're doing SIGINT or IMINT or Intel or any other kind of Intel, the tags you put on that data, the way you format it, the way you hold it in memory or hold it on the hard drive, put it in a database, it's very specific on what you're doing with your data and the questions you're trying to answer. So interoperability between the meshes is what you really need to concentrate on. And what I mean by that is, when your data comes out, it's got to be in a format when it's presented to everybody. It's got to be in a format and wrapped in a way that people can recognize it and protect it. And for us, it's not just classification as protection. We've also got civil liberties, things like that, that we have to protect as well. So you've got responsibilities, we call them oversight responsibilities, on your data, along with your security responsibilities. When that data leaves your possession, you've got to figure out how to monitor that and meet your obligations, which is a little bit more difficult than just handing a package over. So the way you do that is you get your metadata standardized as good as possible. And this is an interesting conversation, because usually when you bring up metadata, everybody goes to, what's your first guess? Anyone want to try? Ontologies. No one's suffered the ontology wars. Well, the ontology wars are alive and well in DoD Intel. Everyone's got their own ontology that they want, and they want to enforce it on everybody. Again, I'm not a big fan of that. I think ontologies are extremely important for putting your data into context. However, enforcing a universal ontology is probably going to work against us and slow us down. So an interoperable ontology I am okay with. But it's more than ontologies. Metadata is about semantic tags, like I discussed. It's also about lifecycle management, which I mentioned previously. Being able to track your data through its lifecycle, ensure that it's deleted when it's supposed to be deleted, ensure that if somebody sees it that shouldn't see it, the reports are done and we do the cleanup properly. And most importantly, I think, getting a return on investment for our data. Like understanding what our products are doing and the value that we're deriving out of them. When you're talking about the amount of data we talk about in this data deluge, that is not an easy thing to do. If we want to evaluate whether we're getting our money's worth out of our satellite constellations, that's a big task. So that lifecycle management is also very important. Provenance tracking, I think that goes without saying. We need to know where the data comes from and who's touched it, and so we know the value and the integrity of that data. We also need to worry about security. Like I said, that's an easy one, security and handling. Security and handling seems very easy at face value, right? I mean, that's straightforward. Security is straightforward. Handling is not so straightforward. And what I mean by that is, need to know is not secret. It's not unclassed. Those are classifications. Those are easy to wrap something in. They're easy to track. They're easy to define. Getting to a more discrete need to know is a much more difficult task, because that need to know will ultimately be based on what you do for a living, right? Who you are, what accesses you have. Some of that is built in, most of it is not. And what I mean by most of it is not is right now, we're building a data-centric ecosystem with data services while we're simultaneously building zero trust. Anyone familiar with zero trust? So as we implement zero trust, those NTK tags become paramount. That need to know access every time you get challenged, they have to be defined. They have to be defined in a way that, okay, like in an HR system. If you want line managers to be able to see PII or personal information on all of their employees, well, that's fine. You've got to build an attribute for that to assign to the manager, and you've got to build a tag to go on the data if you want that to happen in an automated fashion. Otherwise, we're not really embracing data centricity. What we're doing is we're assigning roles to people based on an administrator going in. And I mean, we're right back to the 90s with an access control list at that point, right? It's not automated, it's not real time, it's not trackable, it's not dynamic. All right, so zero trust. As we roll it out, these NTK criteria have to be translatable across our data meshes. What I mean by that is if we're using certain need-to-know criteria in one agency, when it goes to another agency, they have to be able to make sense of that tag or what it means, or they need to leave it off the table. So back to the ontology wars. We don't need to enforce universal need-to-know criteria in every organization. We need to enforce interoperable need-to-know criteria and leave it up to DIA or NSA or NGA to define who has access to what in their own environment. Leave the combatant commanders the freedom to assign who gets to see what in their environments, but have a way to translate those need-to-know criteria across those boundaries. So, I talked about the data mesh. I don't know if anyone's familiar with the IC data reference architecture, but that was a big effort that the IC CDO did last year. They kicked it off in February. They had it done by October. I think it was signed later, but it was finished by October. That is a very robust blueprint for a federated interoperable data mesh. It's one of the first ones I've seen done like this. I think it was done very well. If anyone wants to go take a look at it, it's worth your time. They have created a releasable version below the FOUO level, so you can get that. All right, any questions so far? Okay, so data as a team sport, all right? It truly is. So one of the other problems you're gonna find as you're trying to roll out data initiatives in the Department of Defense is the authorities for those data lie in different places in different organizations. So security authority is one very well-defined authority in DoD. That's not sitting with your chief data officer. Chief data officer has their authorities. Data stewards have their own authorities as owners of that data. But then we also have IMOs. So these are the management officers that track what we do with our data and protect civil liberties. So they have oversight responsibilities for our data and how we do intelligence. If you're not talking to all four of them when you're making your metadata schemas or making your decisions, you're gonna run into a roadblock somewhere. So if security's not on board, if IMO's not on board, if the data steward's not on board, if the chief data officer's not all on the same sheet of music, you're not gonna have an orchestra, you're gonna have a crash. So it's very important to get everybody on the same page and have their concerns addressed in your schemas. So right now in the Department of Defense, we've got a lot of initiatives going on. I think the promise of what AI and data can bring is there, but the reality of what we have to do now is a little less flashy and a little more like, mining work. You gotta get your head down and dig in. So one of the big things we can tackle now while we're transforming our networks is automated report generation. That's a huge problem in the department. It's a very huge problem in Intel. Taking all of this disparate data and having automated reports put out is an immediate payoff for us. We can do it now with the technology we have, and it frees people from the tedious obligations of going in and looking at this and looking at that. Prioritize data triage. So within this deluge of data, you've got to know what's important and what's not. AI is extremely helpful at going through all of our data holdings as they come in and allowing us to tag them on ingest based on what we're seeing and put it into a useful format right away, rather than requiring an army of analysts to pore over it and then, a week or two later tell you what value was in there. So what advantage will that bring us when we do these things? Right now, the biggest advantage that we are trying to use AI for is enhanced threat analysis. We're trying to look at all of the data we have and figure out where the threats in that data are and get it to decision makers as quickly as possible. Again, easier said than done when you're talking about terabytes and terabytes streaming off of all of our sensors. Putting that in a format that's understandable in just one sensor is hard enough. When you're trying to look for clues across multiple sensor data sets, it becomes a much more challenging problem. And we're not going to be able to do that without AI. Excuse me. Proactive threat prediction is the next thing we're looking at. And what we mean by that is we look at our historical data, we look at past behaviors, we look at what we've seen in the world previously, tips, cues, whatnot, and we kind of make a prediction that, yeah, this is what we're seeing. When this happens and this happens and this happens, these are your likely outcomes. So that helps inform decision makers of the threats and the problems they're looking at. Now, the next one, probably the biggest and dearest to my heart, is accelerated target identification tracking. And that's, I already mentioned that a little bit earlier, being able to look between IMINT and SIGINT and other sensors and say, okay, this is what we're seeing, this is what we believe it is, and this is where we believe it is right now, is hugely important. And that's going to be even more important to the department as the department takes more automated operations into its bag of tricks, if you will. So being able to get that real-time data product to a decision maker in the field so that they can track a threat in near real time is what we're striving for right now. And AI and data do make that possible, but we've got to get the processes in place to make that a reality at scale. Okay, so overcoming the challenges of securing this future that we're talking about with AI, biggest thing we need to do is we need to start working more closely with industry. I won't put out any company names, but obviously for the last 20 years, there's been a lot of companies doing a lot of work on predicting behavior and analysis on the data that they collect on us. We need to be able to take that and turn it towards what we're doing. Safe, secure, reliable way, but rather than try to reinvent the wheel, just take on what has already been done. The biggest challenge to that is get your data right in the first place, like I said. Being able to do that cross-functional tipping and queuing, that looking through the data sets. The other problem is the way we do security in the government is much different than the way security is done in the commercial world. PKIs, for instance, things like that. The way we use our certificates, the rules we have, don't always work well with commercial products. I'll give you an example of this, and you talk about it. When we take something from the low side and we move it into a classified network, those classified networks don't operate the same as a low side network. There's not, the same services aren't available, the same capabilities aren't there. So a lot of tools are built based on, like if you're building something in one company's stack, you're building it based on their basic services and tools. When you take it out of that environment and those basic services and tools aren't there, you've got to rewrite all that code. So these packages, when we bring them up, need to be able to run within our security environment in a way that can be monitored, in a way that can be reported, in the way it needs to be done. And again, that's easier said than done. So trying to build your systems or help us integrate your systems faster and easier is a big goal of ours. We need help managing data at scale. I mean, that's plain and simple. There's no guile in that at all. Data at scale for us is a big challenge, and it becomes an even bigger challenge when you look at our architectures. So we ran the war on terror for the last 10 years out of the Amazon Eastern Cloud region, right? AWS East. The next time we go to war with a near-peer competitor, that will not be sufficient for a battlefield commander. We cannot expect that they're going to be able to reach back and use cloud resources from CONUS. So we have to be able to deploy a robust network forward that would allow that commander to continue operations even if they're in a denied environment. Does that make sense? Again, that's not trivial. A lot of cloud providers offer you a cloud in a box, but you've got to figure out what compute and storage you need at the edge and then maintain it, which is a challenge. But we do need to commit to embracing that edge computing capability because the battlefield commanders have a lot of assets at their disposal. So having them be able to continue operations, AI operations at scale during a conflict is very important. We need to foster a culture of innovation in DoD, and that's not always easy as well. We got a lot of people who are very eager to apply AI, very eager to do data operations, but the processes that we have and the rules that we have in place don't always empower that. And I can talk about that a little bit more if you'd like. So the technology really isn't the problem. Right? The problem is we do things a certain way, and no one, excuse me, I've had a real bad cold all week. I thought I was over it, but we wanted to drink. The way you do things matters, right? And the way we do things now aren't built in a digital fashion. They were built on analog methodologies, if you will. And the first thing we're trying to do now is digitize an analog process. And since I would say we're not fully ready to embrace the completely new processes, that's not a bad first step, but it's got to be a first step. That's got to be what you keep in mind, that we're doing this now so that we can enable a new process down the road. Something faster, something more agile, something that brings us value and answers our questions in a different way. Examples of that would be using non-traditional data sources, like open source information. That's become very popular, but merging that in with some of our more traditional collect is a challenge that we need to be able to tackle in the very near future. I would also say that retaining the talent in government is not the easiest thing in the world. So I've been a career development officer for data for about 10 years now. And we can recruit people out of college with some success, but the 5-year retention rate for those people is extremely low, alarmingly low. And I mean, it's very simple. You're a young person right out of college and you could double your salary. That's not a hard decision for some people. So developing a way to keep that talent in-house would help. That's not really a problem you can help solve, but also being able to partner with you to leverage some of that expertise is a problem you can help us solve. So keep that in mind. All right, so the road ahead. We want to integrate AI across all of our intelligence operations. We want to integrate it right now. First step is we use the AI to do subroutines. And what I mean by that is the very tedious things that a lot of analysts do. You can have the AI do that once we validate the process. We have a good model for it. We have a good documented model card that we can monitor. We can monitor for drift. Then the analysts don't have to do that anymore. All we have to do is monitor that the process is working properly, and we can take the inputs into our overall analysis. The next piece that we need to address after that is validating more automated algorithms for compiling that AI. So taking those sub-processes that we can routinely do now and bringing it up a stack and letting the AI compile that into a finished product. The challenge there is the validation, right? That is not the easiest thing to do. Our intelligence process is very analog. Going through it and saying, okay, this AI is doing this and I can trust it as an intelligence product is going to require explainable AI. So like if we're using LLMs, we need the LLM to be able to come back and explain to us in a very clear way, this is what the machine did And this is why the machine is giving you this information. The more we can do that, the faster we can adopt AI. And if you take anything else away from today, please take that away. The more we can do that, the faster we can adopt AI. So we have to get our sub-processes validated, we have to get the compilation processes validated, and then we must have a way to monitor that those things are working properly. We can get those three things done, and we can explain it to the decision maker, we're ready to take the step. And that's where we really need to drive this. Yep, okay. So, last thing I would say we need to do is not only invest in our workforce and the talent, but invest in our infrastructure, like we already talked about. Not only in the cloud-based stuff, but in our edge compute capability and in deployable packages in ways that we can continue operations anywhere in the world at any time using our AI tools. We get the talent to do that. We get the networks to do that. We build our networks to be more resilient. What I mean by that is data orchestration. Anyone's familiar with that? Have the AI help us figure out that, okay, here's your total bandwidth. These pieces are down right now or degraded. I'm going to route everything this way. Here's your most important data. I'm only going to send that because that's all I have the room to send, those kind of things. And that's all there for the taking. We just have to operationalize it. So talent, networks, and validation processes. Those are three big challenges. Any questions? Go ahead, sir.
Michael Kaplan, Rocket Software. Can you wrap a little more detail around how you go about the process of validating the data before you ingest it into your AI model? For example, you're developing and you're expanding on the large and small language models, right? And are you using first known good data after you go through the process of an algorithm type integrity check of the data? And also, is it coming from external sources? Once it comes from the external source and it's validated, does it only stay internal at that point? And once the data is internal, right, and you validated that it's trusted, what's the ongoing process to ensure that the integrity and the trusted data stays true?
All right, so there might be some ambiguity in the terms you're using. So I think the question is, how do I validate data on ingest, or how do I validate data for intelligence work? Which one? Okay, so validation on ingest, if it's a new data source, it's going to take some data, right? We're going to have to play with it for a little while before we know that what we're looking at is in fact the right thing. Validating on ingest is becoming easier because of AI. However, you need a sample size large enough to be able to say, okay, this is good. Now, the good news for us is most of my data is pretty well regulated. I know what I'm getting off my sensors. I know what it should look like. So in those cases, we make sure that all the rows are intact, all the timestamps are right, little things like that we can do for data quality to make sure that, okay, this data is good. You also need to be able to alert if something changes there. That's what I'm talking about, monitoring for drift. So if I lose a row, somebody needs to know that, especially somebody who's counting on the information in that row to be there. And knowing how the algorithm is going to perform without that row would also help. Is it going to give me an answer, just a bad answer, or is it going to not work? Unfortunately, it usually just gives you a bad answer, which is something we need to know. Now, when I'm talking about validating for intelligence work, now I'm talking about validating my algorithm to follow the intelligence process and to make sure that we've done the analytic rigor required for us to validate it as an intelligence product. You can look up ICD 103 if you want later on today. There is a very rigid process in place. It is very, very hard to get people who are steeped in that process to think that a machine could do any of it, but it can. But that's where we start with the sub-processes. Okay, it's not going to give you the final product, but it's going to do these 5 things that you do to the data that you compile. Validate that those work, get confidence, make it explainable, then you start raising everybody's confidence level in what's going on. Then you can take that next step of having the AI now compile those 5 subroutines. Have I answered your question? Okay. But the rigor, the analytic rigor is the hard part. right? You've got to have an analyst sit there and say, okay, yeah, if you do this, and you do this, and you do this, and you do this, then I will take the output. But then you also have to guarantee that you're monitoring for changes in drift. Go ahead.
AI hallucinations, talking about large language models, talking about data drift. I mean,
Yeah, so the hallucinations are a concern. I talk about, and when I'm saying drift,
say it yet, so I'm wondering if it is concerned.
no, it is a concern. It's not a concern I know how to tackle just yet, though. That's why we're starting with these subroutines. In the end, the large language models are a concern for me. Now, just like everything else with AI, IMIT and SIGINT are easier than the other intelligence because those are very huge data sets. They're very well known. They're standardized, right? They're coming off a satellite. They're coming off a known sensor. We were able to, if you're familiar with Maven and the Jake, they were able to jump into computer vision very early because they had enough data to do it, and it lended itself to that. Not the same for human operation, obviously. A lot more risk there. So LLMs for SIGINT and IMINT, I think, are attainable in the near future. LLMs for, hey, answer this problem, are going to be much more problematic. And that is some people's goal, to type in, what's my threat from country X?
How much of that can be mitigated from a RAG approach? You have a cloud in the box. With AI, LLM, that's only being fed and monitored and utilizing the data that you guys have provided with guidance.
Right.
And conjugate guidelines.
Well, I mean, we have our own private network anyway in that time. It can be mitigated. Controlling the amount of data that goes into the LLM is definitely an approach. That's why I'm going back to SIGINT and IMIT. We have enough data. We've got more signals data than any other data holder. That's the one place that we're not behind the commercial world, right? So we can do that in a controlled environment. We just have to have the expertise to apply the models properly. That's where the rub comes in. Yeah. All right, thanks. Sorry if I went over. All right, I appreciate everyone's time.